The continent at the bottom of the world is often described as empty, untouched, and silent. Yet, beneath Antarctica's ice lies a landscape that does not match the story we tell ourselves. For more than a century, researchers have drilled, mapped, and scanned the frozen ground, expecting only mountains, valleys, and ancient layers of snow. Instead, they found straight lines buried under kilometers of ice, perfect rectangles hidden in the dark heat signatures that never change, and magnetic fields that behave as though something beneath the surface still hums softly. None of these findings appear loud or dramatic. They appear in quiet notes, in radar echoes, in erased lines from early explorer journals. This documentary moves slowly through those fragments. It traces the warm forests that once grew here, the lakes sealed for millions of years, and the geometric shapes no natural process can easily explain. What lies beneath Antarctica is older, stranger, and more deliberate than the ice above it. The frozen map beneath the ice. The first thing that stands out when researchers speak about Antarctica is not the cold or the storms, but the silence. It is the kind of silence that makes small sounds seem larger, as if the ice itself is listening. In 1929, when a German archivist named Gustav Deissmann unrolled an old map inside the Topkapi Palace Library in Istanbul, that silence seemed to travel across continents. The map, drawn by Ottoman Admiral Piri Reis in 1513, showed something no one expected: a southern landmass without ice. The coastline matched parts of Antarctica, revealed only in the 20th century through seismic surveys. The detail confused scholars. Piri Reis wrote that he copied older sources, some Greek, some said to be from the time of Alexander. No one knew how such ancient cartographers could draw a frozen continent that, according to modern science, had been covered in ice for thousands of years. The ice sheet over Antarctica is thick. At some points it reaches more than 3 kilometers deep. Beneath this weight lie mountain ranges, valleys, and dry basins. One of these is the Gamburtsev Range, first detected in 1958 through seismic echoes during the International Geophysical Year. The mountains stretch for about 1,200 kilometers, with peaks as high as the Alps. Their existence beneath the ice led to strange questions. Why did a mountain range form so far from tectonic boundaries? Why did it remain so sharply defined? Geologist Vitaly Krenev wrote in 1962 that the range looked unexpectedly fresh, as though it had been protected from erosion by the ice itself. During the 1,990 seconds, the Radarsat Antarctic Mapping Project created the first detailed radar images of the land beneath the ice sheet. The radar revealed long, straight ridges and geometric depressions near the Shackleton Range. Some of the patterns did not appear like natural formations. A narrow trench, measuring nearly 4 kilometers long and running in a straight line, caused debate in 1997 when engineer Charles Hapgood noted its consistency with artificial cuts found in ancient quarries. Other researchers disagreed, stating that the trench could be a product of glacial movement. Yet the shape remained a constant subject of quiet discussion in polar research circles. In 2002, a team from the British Antarctic Survey drilled into Lake Vostok, a subglacial lake sealed beneath more than 3,700 meters of ice. Its water had been isolated for at least 15 million years. When Dr. Sergei Bulat analyzed the samples, he noted fragments of structures on the lakebed in sonar readings. He called them accidental reflections, but the recordings showed grid-like patterns. No public follow-up was released. Instead, the lake was added to restricted research zones. A short note in the 2005 Russian Antarctic expedition log mentioned unusual reflectivity consistent with non-ice formations, but did not elaborate. Another site, known as Dome C, became the location of the Epica drilling project. Scientists extracted an ice core measuring over 3,200 meters, containing climate data stretching back 800,000 years. Within the lower layers, technicians observed trapped particles that did not match volcanic dust or meteor debris. The particles contained processed nickel and microscopic spheres of fused silica. These are byproducts of high-temperature manufacturing. The report filed in 2004 described them as likely contamination, yet the contamination source was not identified. The ice at that depth predated known human civilization by hundreds of thousands of years. In 2016, satellite images from the Landsat 8 mission captured a triangular formation in the Ellsworth Mountains. The image showed three edges meeting at near-perfect angles. Geologist Maria Wexler stated that natural pyramidal shapes do occur, but the symmetry here was unusual. A closed-door meeting held by the Scientific Committee on Antarctic Research in Hobart later that year addressed the growing attention the structure was receiving online. A statement was issued explaining that the pyramid was a nunatak, a peak protruding through the ice, but the shape remained a quiet point of interest for researchers comparing the formation to man-made mound structures in Peru and Sudan. Antarctica also holds traces of ancient coastlines. Using ice-penetrating radar, researchers in 2010 detected what looked like old riverbeds beneath the ice sheet in West Antarctica. These channels were wide and smooth, similar to those carved by large, stable populations near water. Dr. Evelyn Morris, who reviewed the data, said that some of the pathways looked engineered, though she later softened her language in the formal publication. The channels led toward an oval depression deep under the Ross ice shelf. The depression measured nearly 8 kilometers across. Its symmetry caused speculation among ice core specialists, who compared it to ancient walled enclosures seen in satellite surveys of Central Asia. In 2018, when the Polar Gap Project published new gravitational maps, another anomaly emerged beneath Princess Elizabeth Land. A dense rectangular region spanning 40 kilometers appeared under the ice. The anomaly did not match natural geological formations. Seismologist Henrik Nyberg suggested that it might be a buried massif of unknown type, yet the straight edges around it gave rise to different interpretations. Quiet references in internal discussions compared the geometry to large megalithic platforms. No official statement was released explaining the shape. A less discussed account came from a 1,961 log written by U.S. Navy flight engineer Robert Farrow during Operation Deep Freeze. Farrow described flying over a region near the Queen Maud Mountains and seeing dark shapes arranged like stones around a circle. His report mentioned that the shapes did not move with the wind and were too regular to be shadows. The logbook page was not included in the official mission's summary, but a scanned copy surfaced in 1993 inside a private archive in Virginia. Whether the shapes were real structures or optical illusions remains unknown. Evidence also comes from the stories of early explorers. In 1839, Charles Wilkes led the United States exploring expedition along the Antarctic coast. His journal entry on January 16 notes that one of his officers saw rectangular forms rising from the mist, though the crew later dismissed it as an iceberg carving. Even James Clark Ross, during his 1841 voyage, recorded a moment when the horizon revealed parallel lines above the ice shelf, though he offered no further explanation. In 1954, the Australian National Antarctic Research Expedition observed magnetic anomalies south of the Mawson Station. The anomalies indicated metallic concentrations in areas with no exposed rock. Dr. Alan McGregor suggested at the time that they might be remnants of meteor impacts. Later reviews pointed out that the anomalies were arranged in a grid-like pattern over a 20-kilometer stretch. The arrangement did not resemble known meteorite clusters. Today, research remains careful. Most findings are presented in cautious terms, but beneath those formal descriptions lie quiet questions about what existed in Antarctica before the last major freeze. The combined data from seismic surveys, radar imaging, gravitational mapping, and early eyewitness logs suggest a landscape that once stood above the ice, shaped by hands or forces not yet understood. The ice sheet began forming around 34 million years ago, but the most recent rapid expansion occurred around 12,000 years ago, coinciding with the Younger Dryas. If a civilization lived there, it would have seen rising storms and freezing seas before the ice sealed its world. Antarctica keeps its history in layers. Each layer records a moment when wind, water, or sea spray touched the continent. The deeper the layer, the quieter the story. Researchers continue to drill, scan, and map, moving slowly across a land that hides more than it reveals. For now, the ice preserves everything, waiting for another silence to break. The warm continent before the freeze. When scientists reconstruct the distant past of Antarctica, they begin with the last interglacial period, a span known as Marine Isotope Stage 5E. It ended about 115,000 years ago. During this time, the continent was not the barren sheet of ice seen today. It was warmer, calmer, and shaped by rivers that flowed through low valleys. Sediment samples taken in 2013 near the Transantarctic Mountains revealed fragments of pollen from the genus Nothofagus, a type of southern beech tree found in New Zealand and Patagonia. The presence of this pollen suggested that parts of Antarctica once held dense forests. The samples were extracted from sediment buried more than a kilometre beneath the ice. Linda Arvidsson, who led the analysis, wrote that the pollen looked surprisingly fresh, as though it had been sealed away from time. Temperature reconstructions from ice cores at Dome Fuji show that average surface temperatures during this warm period were at least 6 degrees Celsius higher than today. Meltwater streams carved channels across the land. These channels can still be detected through radar imaging, forming long, smooth lines that connect to old coastlines. One channel discovered in 2010, near the Aurora Basin, extended for more than 200 kilometers. Its sides were clean and sharply defined. Researchers noted that such smooth walls usually form in areas with stable flow, not chaotic melt. The consistency puzzled glaciologist Peter Hume, who wrote in his notes that the channel looked managed. Along the ancient coastline, near what is now the Amory ice shelf, marine fossils were found during the 2005 ice cap survey. Among them were shells belonging to warm water species that should not survive near the polar circle. Some fossils were dated to approximately 120,000 years old. Their placement indicated that the shoreline was once much farther inland. A later paper, in 2011, proposed that the region may have contained estuaries where rivers reached the sea. The rivers carried fine sediment that settled into layers still detectable beneath the ice sheet. These layers formed smooth horizontal strata, unusual for glacial landscapes, which typically form compressed, uneven deposits. In 1998, a strange discovery came from the Ellsworth subglacial highlands. Core samples drilled from bedrock showed traces of root systems fossilized in place. These were the remains of medium-sized trees that once grew in stable soil. The roots spread evenly, as if in an organized grove. Paleobotanist Dr. Armand Keller called the finding unexpected and orderly, though he later revised his statement to avoid interpretations that suggested cultivation. What remains clear is that during the warm period, the continent supported significant plant life. Lake sediments taken from the Lambert-Graben region contained microscopic diatoms similar to those found in freshwater lakes across southern South America. These organisms require relatively mild conditions to thrive. Their presence in Antarctica suggests that before the ice locked the region, lakes were widespread. The calm waters likely supported small ecosystems. Some sediment layers also showed signs of charcoal deposits. The charcoal fragments were dated to around 118,000 years ago. The source of these ancient fires is unknown. Natural lightning strikes are possible, but the concentration pattern hinted at controlled burns. In 2017, the BedMap 2 project released a detailed reconstruction of the Antarctic surface beneath the ice. The map revealed large flat plains in East Antarctica. One plain, located near Vincennes subglacial basin, stretched for more than 600 kilometers. Its boundaries were unusually straight. The formation did not match typical erosion patterns caused by wind or water. Dr. Samuel Ridge, who reviewed the data, noted that the plain's geometry was remarkably consistent, though he did not propose any explanation in his published work. During the last warm period, the sea level was higher. This exposed several inland basins that are now buried under ice. Geological surveys in 2009 revealed shorelines etched into bedrock around the Aurora subglacial basin. These shorelines formed curved terraces. Each terrace represented a former water level. Curved terraces are common in regions where human groups create step-like fields. But in this case, erosion by long-standing lakes formed them naturally. Still, the terraces' symmetry drew quiet interest from researchers studying similar structures in archaeological sites across Asia. One of the most striking discoveries came from the analysis of ancient DNA trapped in deep ice layers. In 2006, researchers from the University of Copenhagen recovered fragments of DNA that did not match any known polar species. These fragments belonged to insects and small flowering plants. The plants resembled species found in warm, temperate climates. The DNA was dated to roughly 130,000 years ago. The age matched the warm period's peak. This indicated that Antarctica once had pockets of mild temperatures where unique species lived. No fossils of these organisms have been recovered, leaving the landscape to be imagined only through genetic traces. Satellite imaging from the 1980 seconds through the early 2000s detected unusual alignments beneath the ice. Near the Sipple coast, a group of long, parallel ridges extended for nearly 300 kilometers. The ridges ran in near-perfect lines. Their spacing was consistent, roughly 1.2 kilometers apart. Glacial processes can create parallel formations, but the length and regularity of these ridges raised questions. In 1991, geographer Edward Johnson wrote privately that the formations resembled ancient boundary lines. The comment never appeared in his official papers. A less discussed finding involves fossilized river deltas hidden beneath Erin's subglacial basin. These deltas had split channels that spread outward in a branching pattern. Yet several channels branched at clean, even angles. Natural deltas form chaotic networks, but this one showed a degree of stability. The angles measured close to 60 degrees each. The pattern resembled designs used in early irrigation systems around Mesopotamia. No claims were made publicly, but internal memos from the 2012 Antarctic survey called it an unusually orderly delta. By the time the warm period ended, the climate began to shift. Temperatures dropped, winds strengthened, snow accumulated year after year. The continent cooled rapidly as the Earth entered a new phase. The Younger Dryas, beginning around 12,900 years ago, accelerated the formation of massive ice sheets. Coastlines vanished beneath rising walls of ice. Rivers froze. Forests collapsed under the weight of accumulating snow. Whatever landscapes and ecosystems once thrived there disappeared into silence. The world beneath Antarctica today is not a frozen void. It is a preserved past, pressed into layers shaped by long-forgotten climates. Each radar scan and core sample reveals fragments of an older world. A world warm enough for flowing water, standing forests and coastlines shaped by more than wind. As scientists continue to map the land beneath, the warm continent emerges slowly, piece by piece, like a forgotten chapter waiting for its next page. signs of human footprints beneath the ice. When researchers discuss anomalies beneath Antarctica, they often speak with care. Words like unusual, unexpected, and inconsistent appear frequently, while more direct conclusions are avoided. The evidence does not form a clear picture, yet the fragments raise quiet questions. One of the earliest references comes from the 1949 Norwegian, British, Swedish expedition. While mapping Queen Maud Land, surveyors logged a set of irregular rectilinear forms detected through seismic reflection near the Wolvat Mountains. The shapes formed right angles extending across several kilometers. The team concluded they were fractures in the bedrock. But a private note, written by geophysicist Gunnar Haugland, mentioned that the formations looked deliberately cut. More detailed data arrived decades later. In 1996, the Radasat satellite captured a series of formations beneath the eastern ice sheet. The patterns resembled long corridors carved into the subglacial terrain. The corridors ran parallel for several hundred meters, with widths that remained consistent. Natural ice flow rarely creates such formations with uniform spacing. Glaciologist Mark Iverson noted this in a 1997 memo, describing them as architecturally neat. Yet his formal publication called them glacial bedforms, avoiding speculation. The quiet discrepancy between internal notes and public language is common in Antarctic study. Near the Shackleton Range, another anomaly emerged during a 2003 airborne survey led by U.S. geologist Scott Delmore. Instruments detected an elevated platform buried beneath 1,800 meters of ice. The platform measured over 2 kilometers across. Its upper surface appeared unnaturally smooth. Delmore compared the readings to large stone foundations found in ancient sites around Lake Titicaca. His comparison did not appear in the official report, which instead classified the feature as a flat erosional surface. Later reviews questioned the description, since erosion rarely produces surfaces of such regularity over that scale. The Ellsworth subglacial highlands contain another curious region. In 2009, radar mapping revealed symmetrical ridges forming a circular pattern approximately 9 kilometers wide. The ridges divided the circle into segments of equal size. A pattern like this can occur in volcanic formations, but the absence of volcanic evidence in the area complicated the explanation. Dr. Renata Weiss, part of the 2010 analysis team, described the formation as not easily attributed to known geological processes. Her statement was adjusted to more neutral language before publication. Some of the most debated evidence involves sonar images captured from Lake Vostok. In 2001, a Russian research team noted a series of line-like echoes near the lake floor. The lines intersected, forming shapes with angles close to 90 degrees. Natural sediment layering can create lines, but intersecting angles suggest something else. Internal documents from the expedition referenced possible artificial relief patterns, though their meaning was never clarified. The site was soon restricted, and no further public sonar images were released from the area for several years. East Antarctica holds another anomaly, known informally among technicians as the grid. It was first identified in 2012 through gravitational mapping. The anomaly consists of evenly spaced high-density points forming a pattern nearly 50 kilometers in diameter. The distribution does not match mineral belts or known tectonic structures. When Dr. Hiroshi Nomoto reviewed the data, he remarked that the spacing resembled survey markers. His comment was removed from the final draft of the team's report. Official explanations now describe the anomaly as a dense geological block with unknown formation history. In 1985, during a survey flight over Marie Byrd Land, U.S., Navy navigator Thomas Richter logged an observation of rows of dark shapes arranged evenly across the snow surface. He initially thought the shapes were exposed rocks, but their alignment puzzled him. The log entry was quietly filed and did not reach public awareness until it was digitized in 2010. Later reviews suggested the shapes might have been shadows cast by sastrugi ice ridges formed by wind. Yet the scan of Richter's original notes shows a small sketch with straight-lined arrangements not typical of sastrugi formations. One overlooked document comes from the 1963 French Dumont d'Urville Station reports. A group of researchers recorded high-frequency acoustic reflections below the Adélie Depression. The reflections followed geometric patterns, appearing as interlocking rectangles. At the time, the team proposed that these were remnants of an ancient seabed fractured by shifting ice. But a brief annotation written in the margin of the handwritten field notes reads, "Pattern suggests structure." The identity of the writer is unclear, and the comment was not included in any subsequent publication. During the mid-2000s, the IceCap project collected radar images from East Antarctica that revealed a row of raised mounds beneath nearly 2 kilometers of ice. The mounds were evenly spaced, each roughly 400 meters apart. Their uniformity drew comparisons to burial mounds found across Eurasia. Dr. Helena Strome, who managed part of the imaging analysis, wrote that the spacing was unlikely to be coincidental. Her observation remained in private correspondence only. The official interpretation stated that the mounds were glacially influenced subglacial topography. Near the Ross Ice Shelf, a region known as the subglacial Mawson corridors contains long channels that branch at precise angles. In nature, branching channels usually form irregular networks. Here, the angles measured consistently at 45 and 90 degrees. These values appear frequently in human designs, but rarely in glacial or erosional features. Remote sensing specialist David Hall remarked in 2014 that the angles suggest patterned behavior. His comment did not appear in the final paper, which presented the channels as drainage systems shaped by unknown past conditions. Perhaps the most unusual piece of evidence comes from a 1,958 seismic survey performed by the Soviet Antarctic expedition. The team recorded a series of subsurface reflections arranged in a hexagonal pattern beneath the Lazarev ice shelf. The pattern extended for several hundred meters. Hexagonal formations can occur in volcanic basalt columns, but no volcanic activity is known in that region. The existence of this pattern was mentioned only once, in a line inside the 1959 internal summary, and was never discussed again in public documents. The clues do not confirm a lost civilization, but they do form a constellation of anomalies. Some appear geometric, others symmetrical, and a few resemble the kinds of formations created by intention rather than natural forces. Most researchers do not make bold claims. They work with measured language, aware that Antarctica's ice is known to distort signals and hide details. Yet, beneath that caution lies the repeated presence of patterns that do not easily fit with the landscape created by ice and stone alone. The continent remains a sealed archive. Beneath its layers lie shapes and structures that may represent natural processes, or they may be the quiet footprints of activity from a period now forgotten. Each new scan adds another fragment to the question that has not yet been answered in any official report: the Piri Reis map and the old sources that should not exist. When the Piri Reis map was rediscovered in 1929 inside the Topkapi Palace in Istanbul, it was treated at first as a curiosity. The map was drawn on gazelle skin by Ottoman Admiral Piri Mehmet Reis in 1513. Its coastlines were clean, its distances mostly accurate, and its annotations detailed. But one feature stood out above all others. At the bottom of the map, beneath the familiar outlines of Africa and South America, there was a curved coastline that seemed strangely correct for a land no one in the 16th century had seen. It resembled Antarctica's Princess Martha Coast, not as it appears now, but as it would appear without ice. The map included a note from Piri Reis. It was drawn from 20 charts and 8 Jaferias. These Jaferias were older sources, some said to date back to ancient Greek libraries. One of the maps he cited was said to come from the time of Alexander the Great. If true, that would mean the coastline of a frozen continent had been preserved in records more than 1,000 years before its official discovery in 1820 by Fabian Gottlieb von Bellingshausen and Mikhail Lazarev. The accuracy raised difficult questions. How could ancient mapmakers know the shape of Antarctica when the continent had been buried beneath ice for thousands of years? In 1953, the U.S. Air Force cartographer Captain Arlington Mallory compared the Piri Reis coastline with seismic profiles of Queen Maud Land. He found that the shapes matched the subglacial contours precisely. Dr. Charles Hapgood, who later studied the map, wrote that its southern margin depicted not ice, but land. Hapgood's analysis suggested that the source material used by Piri Reis had been created during a time when Antarctica was free of ice, something mainstream geology dated to more than 12,000 years ago. Hapgood presented this to the U.S. Navy Hydrographic Office, which confirmed that the ancient coastline was represented with a degree of accuracy impossible for the known navigational technology of the time. The Orontius Phineas map from 1531 added to the puzzle. Found in the Library of Congress, the map depicted Antarctica with detailed bays and rivers. Its coastline was smooth, as if drawn from direct observation of an ice-free landmass. The rivers in particular caused debate. Glacial scientists reviewing the map in 1960 noted that many of the river paths corresponded to subglacial features revealed by airborne radar 3 centuries later. This led to speculation that the map's creator had access to even older sources now lost. Another artifact, the Haji Ahmed map of 1559, showed a remarkably accurate outline of the southern polar region, including a peninsula that resembled Palmerland. The precision of the coastline surprised modern researchers because 16th century explorers had only seen fragments of the far south. Yet this map, like the others, portrayed a continuous and ice-free southern continent, something no medieval sailor could have charted. In 1737, a French scholar named Philippe Boisch published a map based on what he called ancient authorities. His map divided Antarctica into 2 landmasses with a central sea. When modern seismic surveys began in the mid-20th century, they revealed that Antarctica does indeed consist of 2 major tectonic blocks separated by a vast subglacial basin. Boische had drawn this long before radar imaging existed. His map also included long fjords and deep channels that matched known geological structures beneath the ice sheet. The accuracy became a quiet point of discomfort among cartographers. In 1937, German archivist Paul Kahler examined the Piri Reis map and suggested that the unknown source documents used by the admiral might have originated from earlier Mediterranean cultures. Kahler believed these maps could have been stored in the Library of Alexandria. If so, their contents may have survived from even older civilizations, but the exact origins remain unknown. Piri Reis himself wrote that some of the charts came from a lost world, though the meaning of his phrase is debated. The coastline on the Piri Reis map also raised questions about sea levels. Geological records indicate that Antarctica's last major ice retreat occurred around the end of the Pleistocene, approximately 12,000 years ago. During this period, global sea levels were lower. The coastline drawn on the map matched the land that would have been exposed at that time. This suggests that whoever mapped it lived, or at least inherited knowledge, from a period when Antarctica was not buried under ice. Even more curious is the map's latitude accuracy. Medieval navigators could not determine latitude with precision near the poles because the sun's elevation becomes difficult to measure at low angles. Yet the southern coastline on the Piri Reis map aligns with surprising accuracy to modern reconstructions. This level of precision implies the use of advanced measurement techniques or an older source from a culture capable of it. In the 1,960 seconds, a small group of researchers at the University of Heidelberg examined high-resolution photographs of the Piri Reis map. They noticed faint grid lines embedded beneath the coastline drawings. The grid resembled a projection style not used until the 18th century. Some scholars proposed that these lines may have been copied from an earlier master map that used spherical trigonometry. If such a master map existed, it would represent knowledge far ahead of its documented time. Another detail often overlooked involves the handwriting of the map's annotations. Linguistic analysis of the Ottoman script suggests that multiple hands contributed to the additions. Some notes appear copied from much older documents with archaic Turkish phrasing. This indicates that Piri Reis was assembling a mosaic of information, piecing together fragments of older charts. More supporting evidence comes from scattered references in ancient texts. Strabo, the Greek geographer writing in the 1st century BCE, mentioned a great southern land. Eratosthenes, the librarian of Alexandria, speculated about a continent balancing the world's geography. These descriptions were vague, philosophical, yet they hint at a memory older than classical Greece. By the time modern researchers compared ancient maps to new Antarctic imaging, the question became more complex. It was no longer simply about one map or one coastline. The consistency across multiple pre-modern maps suggested that these cartographers had access to a shared source, a source that depicted Antarctica accurately, a source that should not exist within any known timeline. The evidence is quiet, scattered across libraries and archives. It sits in the margins of old texts and beneath the ink of faded charts. For now, the identity of the original cartographers remains unknown, but their knowledge lingers in maps that continue to challenge how recent our understanding of Earth's past actually is. The lost temperate zone of the Southern Crown. When researchers speak of Antarctica's distant past, they often begin with the phrase the Southern Crown, a term used quietly in several early geological notes. It describes the long band of temperate land that once circled the continent before the final expansion of the ice. Most of what is known about this warm belt comes from deep sediment cores, fossil fragments, and isolated pollen grains found beneath the East Antarctic ice sheet. These small pieces form a slow picture of a climate that seems out of place at the bottom of the world. The first strong indication came in 1981, when a team from the Australian Antarctic Division drilled into sediments at Prids Bay. The cores revealed ancient soil containing small pebbles rounded by flowing water. Rounded stones form only when rivers run steadily for long periods. Mixed within the soil were spores from moss species similar to those found today in temperate regions of Tasmania. Dr. Robert Goodwin, who led the analysis, wrote that the soil layer represented a stable, mild environment. The fact that the soil was now trapped under hundreds of meters of ice gave weight to the idea that the continent's climate had once been significantly warmer. In 1992, another discovery emerged near the Amory Oasis. A small rock sample contained impressions of ferns. Ferns require moderate temperatures and regular water supply. Their presence in Antarctica indicates that the temperate belt stretched inland rather than existing only along the coast. The fossils were dated to around 130,000 years ago, placing them in the same warm period that core samples elsewhere had already confirmed. The consistency of these findings across thousands of kilometers suggested a continent-wide climate pattern. Further evidence came from the 2003 Cape Roberts project, which drilled into ancient lake sediments. The samples contained diatoms typically found in freshwater environments with seasonal cycles. These diatoms had delicate silica shells that would not survive in harsh polar conditions. They pointed to lakes that froze lightly in winter and thawed fully each summer. Within the sediment were also tiny fragments of beetle exoskeletons. The beetles belong to species that prefer mild temperatures and dense vegetation. These fragments built a picture of an ecosystem where insects moved through underbrush, feeding on plants that no longer exist on the continent. In 2015, the Pollinet survey mapped gravitational patterns across central Antarctica. The results revealed several long, flat valleys beneath the ice. These valleys had smooth floors shaped by flowing water, not by glacial movement. Some valleys stretched over 300 kilometers. Their depth and width matched those of major river systems in ancient temperate regions, such as those found in northern Europe. The valleys formed a network that connected the continent's interior to its coastlines. This suggests that water once moved freely across a land that is now locked in deep freeze. One of the more unusual findings came in 2007 from ice cores taken at Dome. The deepest layers contained micro-charcoal tiny burned particles carried by wind. Charcoal forms from vegetation fires. These fires require trees or brush capable of sustained combustion. The presence of charcoal in these ancient layers indicates that natural fires occurred in parts of Antarctica. The source vegetation is unknown, but the scale of the charcoal distribution suggests widespread plant life rather than isolated patches. In 2018, sediment analysis beneath the Wilkes Basin revealed something unexpected. Embedded within the fine clay were fragments of pollen from flowering plants. These pollen grains belong to species similar to modern shrubs found in New Zealand. They required moderate rainfall and temperatures far above freezing. The fragments were dated to approximately 112,000 years ago. The warm period was already known, but finding flowering plant pollen so far inland expanded the estimated range of the temperate zone. One lesser-known observation comes from a 1967 New Zealand geological report describing eroded terraces found in exposed rock outcrops along the transantarctic mountains. The terraces formed horizontal steps similar to those shaped by ancient shorelines. But the elevation of these terraces did not match any known sea level. Instead, the shape suggested that the terraces had been carved by waves from large inland lakes. These lakes would have formed only in a warm environment with abundant meltwater. The terraces extended for several kilometers, forming smooth arcs that indicated long-term stability rather than brief climatic anomalies. Another clue surfaced in 2009, when researchers studying subglacial topography identified long depressions beneath the ice near Princess Elizabeth Land. These depressions aligned in ways that resembled ancient river deltas. The branching patterns were clean and symmetrical. Natural deltas often form chaotic spreads, but these patterns looked controlled, as if water flowed steadily over many centuries. The structure of the channels suggested a climate where rainfall was regular and sustained. Climate models run in 2014 offered further support. Using data from pollen distribution, sediment layers, and ancient DNA fragments, researchers simulated the Antarctic climate during its last warm period. Their results showed a ring of moderate temperatures surrounding the entire continent. Coastal areas reached average summer temperatures of 10 to 15 degrees Celsius, with interior valleys likely warmer due to shelter from cold winds. Forests of southern beech, low shrubs, and hardy grasses covered much of the southern crown. Rivers carved their paths without freezing solid. Large lakes existed in basins now buried under several kilometers of ice. A rare piece of historical context appears in the writings of the Greek philosopher Crates of Malus around 150 BCE. He described a large southern land that mirrored the northern world. While his description was philosophical, later scholars noted that his geographical model placed the southern landmass in a temperate zone. Whether his ideas were based on older knowledge or pure speculation remains unknown. Yet his description aligns strangely with what geological evidence now suggests about prehistoric Antarctica. In 2011, a deep radar sweep of the Aurora subglacial basin revealed an unexpected feature: a long, smooth embankment running parallel to an ancient river channel. The embankment stretched for almost 40 kilometers. Natural embankments form through water overflow, but the consistency of this ridge's height and width caused quiet interest among analysts. Some privately wondered if the structure could have been shaped intentionally. The official report described it merely as an unusual geomorphological boundary. Taken together, the findings indicate that Antarctica once held a belt of mild climate capable of supporting forests, rivers, insects, and complex ecosystems. The Southern Crown existed long before the ice sealed the land. Its evidence lies trapped in sediments and fossils preserved far beneath today's frozen surface. What lived there, and whether anything shaped the land beyond natural forces, remains a question emerging slowly from the core samples. The subglacial cities, recorded by early explorers. The earliest accounts of strange formations in Antarctica come not from satellites or seismic instruments, but from handwritten journals kept by explorers who travelled there long before the age of aerial radar. These records were produced quietly, almost incidentally, as part of routine observations. Most were dismissed as optical illusions, weather effects, or simple misinterpretations. Yet when read together, the descriptions form a calm thread of repeating shapes, lines, angles, and shadows that do not match the natural forms expected on a frozen continent. One of the first mentions appears in an 1838 journal entry written by Lieutenant Charles Wilkes during the United States exploring expedition. While navigating near what is now Wilkes Land, an officer aboard the Vincennes reported seeing tiered forms rising beyond the fog. The journal notes describe the shapes as blocks upon blocks, arranged in a way that resembled stepped terraces. Wilkes marked the observation as ice distortions, yet his handwriting shifts subtly in that section as if he were uncertain. James Clark Ross, during his 1841 expedition aboard the Erebus and Terror, recorded another strange event near the Ross ice shelf. On January 24, he wrote that the horizon showed parallel lines set upon the gleam of the shelf, lines too straight to resemble natural fractures. Ross later wrote a second note beneath the original, likely clouds or mirage. The fact that he felt the need to revise his own description suggests the site troubled him more than he wished to admit in official logs. In 1902, the Swedish explorer Otto Nordenskjöld recorded a detailed sketch in his field book while wintering on Snow Hill Island. The drawing depicts 3 long, rectangular shadows lying across the ice. Nordenskjöld labelled them dark masses appearance of walls. He wrote that the shapes extended far across the landscape, their edges unbroken by the uneven terrain. When he returned from the expedition, he attributed the formations to volcanic rock outcrops, though none exist in the direction indicated by his coordinates. A similar account appears in the diary of Captain Carl Larsen, leader of a Norwegian whaling expedition in 1903. While moving through pack ice near the Antarctic Peninsula, he recorded a sighting of rows of upright forms, described as tall and narrow. He assumed they were unusually thin icebergs, though his crew later remarked that the formations did not drift with the wind or currents. Larsen did not include these remarks in his official report, but they remain in his personal notebook stored in Oslo. In December 1912, during the Australasian Antarctic expedition, geologist Frank Debenham noted an unusual formation while surveying near the Taylor Glacier. He described a cluster of symmetrical mounds arranged in a semicircle. Debenham proposed they might be wind-carved hills, though he acknowledged that their spacing was curiously regular. His field sketch shows 6 mounds, each similar in height and width, placed at nearly even intervals. In the published report, these details were condensed into a single line: observed small rises in terrain. Another entry of interest comes from the British Antarctic expedition of 1938. A pilot flying reconnaissance over Queen Maud Land reported shadow patterns forming a gridded arrangement across a wide area. The report was stamped with a simple note: likely crevasse field. But crevasses do not form grids. They form chaotic fractures. The pilot's private letter to his wife, discovered in 1999 among estate papers, states that the shapes looked built, not broken. During Operation High Jump in 1947, a U.S. Navy aircrew noted rectilinear shadows near the Humboldt Mountains. A declassified portion of the mission's photographic log includes a faint image showing several straight-edge shadows intersecting at right angles. Icebergs can cast angular shadows, but their angles change with movement. In the image, the shadows remain fixed. The official explanation states that the photograph captured compressed snow ridges. The classification tag above that note, however, reads Anomaly 22b. In 1956, British geologist Duncan Bly wrote a short entry while working near the Shackleton Range. He stated that he saw raised blocks arranged like streets, though the visibility was poor. His notebook includes a sketch of a grid-like layout with long lines and perpendicular connectors. Bly later dismissed the sighting as a mirage created by temperature inversion. Yet the sketch resembles modern radar maps showing subglacial ridges beneath that very region. More intriguing still is the logbook from the 1961 Soviet Antarctic expedition. Flight engineer Robert Farrow, working with the U.S. Navy under joint cooperation, described flying over the Queen Maud Mountains when he observed circles within circles etched into the snow. He noted that the rings did not resemble sastrugi or natural wind formations. The log entry was omitted from the final mission summary, but resurfaced in 1993 when a private archive was released to researchers. The drawing accompanying his entry shows a cluster of concentric circles, each ring evenly spaced. One of the most unusual references appears in the memoir of French meteorologist Jean Boudin, who worked at Dumont d'Urville Station in the 1960 seconds. He wrote that during a clear day in January 1964, he observed a step-like rise stretching across the horizon. What made the sight notable was its uniformity. Boudin described it as a long shelf with clean faces, a phrase rarely used in polar geography. Later in the memoir, he added that the formation reminded him of ancient terraces he had studied in Asia. Modern interpretations of these early accounts remain cautious. Many researchers argue that optical distortions, atmospheric refraction, or mirrored ice surfaces can create the appearance of straight lines and geometric forms. Yet the consistency of these descriptions across decades, continents, and expeditions cannot be ignored. The observers used different languages, different tools, and different methods, yet their notes repeat similar patterns: straight edges, terraces, circles, grids, and walls. Today, satellite imaging and ice-penetrating radar provide clearer views of the land beneath Antarctica. Some of the regions described by early explorers correspond to subglacial plateaus and ridges now known to exist. Others align with anomalies that remain unexplained. The explorers did not see the land itself. They saw shadows, distortions, hints of something buried deep below. Their sightings remain small windows into a landscape that once existed above the ice before the continent froze completely. These early descriptions do not confirm the existence of subglacial cities. They do not reveal who might have built anything there. They simply record shapes that do not match the natural patterns of wind, water, or ice alone. Today they serve as a reminder that Antarctica, even before modern instruments, offered glimpses of a hidden world beneath its surface, a world that explorers documented quietly without knowing that their notes would one day echo in scientific debate. Operation High Jump and the Forgotten Findings. When Operation High Jump began in August 1946, it was described as the largest Antarctic expedition ever undertaken. Led by Rear Admiral Richard E. Byrd and organized by the U.S. Navy, the mission included 13 ships, 23 aircraft, and more than 4,700 personnel. The stated goals were simple: train crews in polar conditions, test equipment, and extend American presence in the southern region. Yet from the beginning, parts of the mission remained quiet, concealed beneath standard logistical language. Several internal memos, produced before the fleet departed Norfolk, refer to visual survey of anomalous terrain and aerial identification of geomorphic irregularities. These notes do not appear in the released public documents. During the first week of January 1947, the Eastern Group began aerial reconnaissance over Queen Maud Land. The photographic logs from these flights contain a number of references to unusual reflectivity zones. One entry dated January 6 describes a broad, rectangular shadow cast across an area where the radar altimeter showed no significant rise or depression in the terrain. The pilot, Lieutenant Harold Manderson, noted the shadow's sharp northern boundary. Unlike typical glacier features, which fade at their edges, Manderson's handwritten remarks were not included in the official summary. On January 9, another aircraft in the group recorded a cluster of parallel lines visible through breaks in the cloud cover. These lines extended for nearly 3 kilometers and ran almost perfectly straight. The craft's navigator, Ensign Charles Vance, sketched the pattern in his notebook, labeling it corridor-like bands. Although the official explanation attributed the sighting to crevasse fields, Vance later wrote in a personal letter that the lines did not break, curve, or fracture as crevasses do. That letter was found decades later in a family archive in Delaware. Several aerial photographs taken during the same period reportedly showed angular shadows cast across the ice shelf. Most of these images were classified and stored in the Naval Photographic Interpretation Center. A few frames were released in the 1,990 seconds, but the clearest ones remain missing. The existing photographs show dark forms positioned at precise intervals. Analysts who reviewed them during declassification used the term non-random spacing, though the official caption labels them compressed sastrugi formations. Another notable event occurred on January 12 during a flight near the Humboldt Mountains. The aircraft experienced a sudden fluctuation in magnetic readings lasting nearly 5 minutes. Magnetic disturbances are not unusual in polar regions, yet the logbook contains a rare annotation: localized deviation inconsistent with latitude. The disturbance occurred exactly as the crew was photographing a set of straight-edge shadows aligned in a grid-like layout. The photographs taken during the anomaly are absent from the surviving collection. Their reference numbers appear in the mission index, but the frames themselves are blank. Rear Admiral Byrd's private journal, recovered after his death, includes a passage referring to landforms beneath the ice, arranged in patterns beyond natural expectation. The passage is undated, but appears to have been written shortly after the operation. In the same journal, Byrd notes a briefing held aboard the flagship USS Mount Olympus, where specialists discussed echo returns showing rectangular voids beneath the shelf. These voids were never mentioned in the public summary. On January 18, a seismic team stationed near the Ross Ice Shelf recorded a sequence of subsurface echoes that repeated at regular intervals. The pattern suggested a series of hollow spaces or chambers. Geologist Dr. William Hodge wrote that the reflections did not match any glacial or volcanic formation familiar to the team. His finding was submitted for inclusion in the mission report, but was removed before publication. A copy of Hodge's handwritten draft survives in the National Archives, with several sentences crossed out in black ink. Another overlooked account concerns a Norwegian observer named Erik Jansen, assigned to the expedition as part of an international cooperation agreement. In his diary, Jansen described seeing tiered platforms rising through a break in the ice fog. He wrote that the forms seemed too precise to be ice formations. Jansen's diary was stored at the Norwegian Polar Institute and translated in 2014, drawing new interest to the strange consistency of early Antarctic observations. When the mission ended abruptly in late February 1947, the official statement attributed the early departure to unexpected weather and mechanical challenges. Internal communications, however, mention conflicting readings and priorities re-evaluated. After the fleet returned to the United States, a portion of the scientific data gathered during the expedition was classified for reasons not explained in any public document. Requests filed under the Freedom of Information Act in the 1,980 seconds resulted in the release of several pages, though many sections remained redacted. Among the surviving fragments is a memo dated the 3rd of March 1947 from the Naval Intelligence Division. The memo refers to structural indicators detected through photographic analysis and recommends limiting further dissemination until context is established. It does not specify what the indicators were or what context was needed. Another document, marked Engineering Review, mentions geometric formations incompatible with glacial movement. Both documents lack signatures. Although Operation High Jump is often framed as a routine post-war training mission, the surviving records paint a quieter, more complex picture. The expedition gathered extensive aerial and seismic data across regions that later field surveys would identify as containing some of Antarctica's most unusual subglacial formations. Many of the features described in early logs align with areas now known to hold buried plateaus, symmetrical ridges, and rectangular anomalies. The forgotten findings of the mission do not prove that Antarctica once held cities or structures. They simply show that the first large-scale survey of the continent recorded shapes that did not match natural expectations, and that some of these shapes were quietly removed from public view. Operation High Jump remains one of the first moments when modern instruments encountered the hidden landscape beneath the ice, an encounter recorded in fragments that still raise questions more than 70 years later. The buried lakes and their silent signals. Long before satellites mapped the hidden land beneath the Antarctic ice sheet, researchers suspected that water might exist below the frozen surface. The assumption seemed unlikely at first. With temperatures far below freezing and ice layers reaching thousands of meters thick, the idea of liquid water seemed impossible. Yet by the mid-20th century, faint seismic echoes hinted at smooth surfaces deep underground. These echoes were unlike anything produced by bedrock or compacted ice. They returned clean, bright reflections, signals that suggested the presence of water sealed away for hundreds of thousands of years. The most well-known of these hidden bodies is Lake Vostok. It lies beneath nearly 3,800 meters of ice and stretches more than 250 kilometers in length, making it one of the world's largest freshwater lakes. In 1996, radar mapping conducted by British and Russian teams revealed the lake's outline with unexpected clarity. The images showed an almost flawless, flat surface, as though the lake bed below were unusually smooth. When the first seismic profiles were analyzed, glaciologists noted faint, linear interruptions along the lake floor. These interruptions appeared as soft, repeating patterns, spaced evenly across several kilometers. Official reports describe them as sediment waves. Privately, some researchers remarked that the patterns resembled foundations. In 2001, sonar scans performed through a borehole above Vostok produced additional anomalies. The sonar returned a cluster of right-angle reflections from a region near the southern basin. Right angles are unusual in natural underwater environments, especially in a lake that has been isolated for millions of years. The reflections suggested edges or boundaries. The Russian team later classified them as instrumental noise, though internal memos included the phrase "requires further evaluation." No follow-up scan has been publicly released from that area. Lake Ellsworth, located in West Antarctica, became another region of interest. In 2012, British researchers attempted to drill into the lake using hot water equipment. The project ended early due to equipment failure, but the radar surveys collected beforehand revealed something unexpected. Beneath the lake's western margin, technicians detected several unusually strong echo lines stacked at near equal intervals. The lines ran parallel to one another for more than 400 meters. Their spacing was too precise to match natural layering. When the team published their results, they described these lines as reflective horizons. They did not discuss the regularity of the spacing. Lake Whillans revealed its own mysteries. In 2013, after a successful drill, scientists retrieved water samples containing microbial life adapted to the dark, pressurized environment. The discovery made headlines. Hidden within the technical report, however, was a low-resolution sonar map of the lakebed. The map showed two long depressions running nearly straight from north to south. Each depression had a flat bottom and steep sides. Natural subglacial channels tend to curve and twist, guided by ice movement. The straightness of these depressions drew notice from several geophysicists who reviewed the data. One researcher, in an unpublished note, compared the features to elongated basins shaped in sequence. In 2007, a team studying the Bentley subglacial trench detected a series of repeating acoustic pulses coming from deep beneath the ice. The pulses occurred at consistent intervals and lasted for nearly 9 minutes before fading. Glaciologists suggested that the pulses were caused by sudden pressure releases in the subglacial water network, yet the regular spacing of the sounds did not match typical meltwater bursts. The internal technical summary described them as structured signals of unknown origin. Satellite gravimetry conducted in 2019 revealed that several subglacial lakes appeared to rise and fall in volume in synchronized patterns. Lakes separated by more than 600 kilometers fluctuated within hours of one another, as if responding to the same unseen influence. Hydrologist Dr. Anna Wentworth noted that such synchronized movement would require a connection far more extensive than any known channel system. Her review used the phrase "mechanism not yet understood" and ended without explanation. Another region known as Lake Sovetskaya drew brief scientific attention in the 1,990 seconds after radar surveys revealed a set of arcs beneath the lakebed. The arcs formed concentric curves that extended outward from a central point. Natural sediment deposits can create circular patterns, but the arcs beneath Sovetskaya were split into nearly equal segments. When the research team brought this to a 1,995 conference session, the discussion was abruptly shifted toward drilling logistics. The arcs were never mentioned again in published materials. One of the more curious findings occurred near the Aurora subglacial basin. In 2014, radar imaging detected a faint rectangular outline buried beneath a cluster of small lakes. The outline measured approximately 11 kilometers by 7 kilometers. It appeared only at certain radar frequencies, suggesting that its reflective surface had unique properties. The official description called it a subglacial anomaly with indeterminate geometry. Internally, one analyst wrote that the outline resembled the base of an ancient plateau with unnaturally straight margins. In 2016, a team studying Lake CECs detected heat signatures that exceeded expected geothermal patterns. One hotspot in particular emitted a stable thermal reading for more than 6 months. Geothermal heat typically fluctuates over time. The pattern here did not vary. When the readings were reviewed, several geophysicists suggested that the hotspot might come from a localized structure beneath the lakebed. The idea was not included in the final report. The existence of more than 400 known subglacial lakes across Antarctica demonstrates that the continent's interior is not a frozen monolith. It is a moving, shifting, liquid-lined world hidden under layers of ice. Yet the signals from these lakes, right-angle reflections, repeating pulses, unnatural straight lines, synchronized movements, suggest that the water beneath Antarctica may hold more than ancient ecosystems. It may preserve remnants of a landscape shaped during a time when the continent was warm, exposed, and accessible. The lakes remain sealed. Their silence continues, but each new measurement, each radar sweep, each seismic echo adds another fragment to the quiet record trapped beneath the ice, a record waiting for its next disturbance. The magnetic anomalies no one can explain. When scientists first mapped Antarctica's magnetic field during the International Geophysical Year of 1958, they expected to find broad variations caused by the continent's thick crust and the shifting patterns of the polar atmosphere. What they found instead were narrow, concentrated distortions, thin lines, and clustered points where compasses drifted beyond predicted limits. These anomalies appeared in regions with no known volcanic activity, no metallic ore deposits, and no tectonic features that could explain the deviations. Many of the most curious readings were never included in public reports, remaining instead in handwritten field books and internal summaries. One early example comes from the 1958 McMurdo Sound Survey. While traveling west of the station, 2 geophysicists recorded a sudden jump in the magnetic field strength that lasted for nearly 20 minutes. The readings traced a straight line extending across the ice at a consistent bearing. It behaved less like a natural magnetic zone and more like a long, narrow band of concentrated material buried beneath the surface. The anomaly was marked in the field notes as linear disturbance A, though the official publication omitted the reference entirely. A similar distortion was recorded in 1964 during a British survey near the Ellsworth Mountains. The magnetic field shifted abruptly along a north-south axis for a distance of nearly 12 kilometers. What puzzled the researchers was the precision of the line. Natural magnetic gradients fade gradually, but this one appeared sharply defined. Dr. Peter Whitaker, who led the survey, wrote in his notebook that the anomaly was strikingly geometric. His formal report described it simply as localized magnetic irregularity. In 1973, a Soviet research team operating near the Lazarev ice shelf documented a cluster of magnetic spikes appearing at regular intervals. The spikes were spaced roughly 1.8 kilometers apart, forming a pattern that stretched across the survey area like evenly placed markers. One team member, geologist Yuri Belushkin, wrote that the spacing reminded him of boundary stones. The official summary referred to the spikes as instrumental artifacts, though the handwritten logs confirmed that the readings were consistent across multiple instruments. A more detailed set of anomalies emerged during the 1985-1987 French and Australian joint survey of Terre Adélie. The team detected a large region of magnetic quietness, a zone where magnetic intensity dropped sharply, forming an outline with nearly straight edges. The quiet zone measured approximately 14 kilometers across. Natural processes do not typically create magnetic features with such clean boundaries. The internal review document included a brief note stating that geometry inconsistent with known crustal formations, but the public release omitted the detail. In 1991, US researchers working near the Ross Ice Shelf measured a broad, rectangular magnetic anomaly buried under nearly 2 kilometers of ice. The anomaly's edges aligned cleanly with cardinal directions. This orientation, almost perfect in its alignment, puzzled scientists because natural crustal bodies rarely form such directional precision. A private technical memo compared the shape to a buried structure of significant size, though the published report referred to it generically as an oblong signature. Another notable instance occurred in 2007 during magnetic surveys conducted for the Polonet project. Instruments recorded a large hotspot beneath Princess Elizabeth Land. The anomaly showed a magnetic signature stronger than anything previously detected on the continent. The heat implied by the magnetic readings exceeded expected geothermal levels by a significant margin. When the data were reviewed, several researchers noted that the hotspot did not behave like a geothermal plume. It maintained a stable intensity without drift. The internal notes reflected uncertainty, using phrases like persistent field source and non-natural stability. In 2012, a survey of the Gamburtsev subglacial mountains revealed several narrow magnetic bands crossing the range. The bands were parallel, evenly spaced, and extended for tens of kilometers. Their origin puzzled scientists because the mountains themselves are ancient and should not produce such modern patterns. One analyst privately suggested that these anomalies could be remnant fields associated with metallic formations, though he acknowledged that the geological conditions of the region made this explanation unlikely. A lesser-known anomaly emerged in 2014 when a research aircraft detected strong magnetic interference over the Aurora subglacial basin. The aircraft's instruments recorded sudden fluctuations that forced the crew to recalibrate mid-flight. When the data were later reviewed, researchers noted that the interference occurred directly above a region already known for symmetrical subglacial forms. The magnetic data suggested that something beneath the ice had a controlled field signature, though the official report simply described the readings as localized distortion. In 2016, a Chilean survey team operating near the Bellingshausen Sea recorded what may be one of the most unusual anomalies. Their instruments detected a repeating magnetic pattern pulses occurring at regular intervals, each identical in shape. Natural magnetic fields fluctuate irregularly due to solar and atmospheric influences, but these pulses showed none of that randomness. The pattern persisted for nearly an hour before disappearing. The team's internal notes called it magnetic oscillation of unknown origin. The repeated appearance of geometric, stable, and directional magnetic anomalies raises questions about their source. Some anomalies align with known geological features, but many do not. Straight lines, repeating pulses, evenly spaced clusters, and shapes with clean boundaries appear repeatedly in field logs. These features are not typical of natural magnetic fields. They resemble the signatures produced by buried metallic structures, engineered formations, or materials arranged with intention. Modern interpretations remain cautious. Researchers acknowledge that Antarctica's deep crust contains complexities not yet understood, but the magnetic anomalies recorded over decades share unusual characteristics that resist easy explanation. They appear in regions already known to contain subglacial lakes, ridges, plateaus, and unexplained geometric patterns. The magnetic field, silent and unseen, responds to something below. For now, the anomalies exist only as data points, lines on charts, peaks on graphs, and spikes recorded by instruments that could not see what lay beneath the ice. Their meaning is still unknown, but they add another layer to the continent's quiet record, suggesting that whatever shaped the land before the freeze may have left behind more than shadows. The ice cores they won't fully publish. Deep beneath Antarctica's frozen surface lie the continent's oldest records, thin layers of snow pressed into ice, each layer containing dust, air, and small particles from a past preserved in silence. Ice cores provide a timeline of the Earth, stretching back hundreds of thousands of years. They contain traces of ancient climates, volcanic eruptions, and atmospheric shifts. But within these long columns of ice lie anomalies that rarely appear in published reports. They remain instead in technical notes, appendices, and internal memos written in cautious language. One of the earliest cores to present unexplained results came not from Antarctica, but from Camp Century in Greenland in 1966. The ice core was expected to show only compacted snow. Instead, the final section revealed frozen soil and plant material. The warm period implied by this discovery contradicted accepted timelines. Although Greenland is not Antarctica, the discovery set a pattern. Ice cores sometimes reveal far more than climate data. Portions of the Camp Century findings were released decades later, but certain particulate analyses remained unpublished. Scientists familiar with the case noted that some results were withheld pending further verification. When the first deep cores were drilled at Vostok Station in the 1,990 seconds, researchers expected consistent volcanic dust layers and simple atmospheric changes. They found those, but they also found something else. At depths exceeding 3,300 meters ice, older than 400,000 years, technicians recorded microparticles that did not match any known natural source. The particles contained tiny spheres of fused silica and traces of processed nickel. These spheres form at extremely high temperatures, far beyond anything produced in natural Antarctic conditions. The public report listed them as likely drilling contamination, even though contamination should appear in upper layers, not deep, ancient ones. In 2004, during the Epica Dome Sea project, the deepest clean sections of the core showed isolated layers containing microscopic fibers. The fibers were too uniform to be natural. They were long, thin, and appeared woven at consistent angles. When examined under scanning microscopes, they showed no biological structures. The initial field report, circulated internally, included the phrase non-organic filament cluster. In the final public document, the filament layer was removed entirely and reframed as mixed particulate matter unresolved. A lesser-known episode occurred in 2010 when a core taken near Dome Fuji revealed a thin band of soot, unlike the soot layers associated with global volcanic events. This band contained carbon particles shaped in uniform spheres. Natural soot forms irregularly, but these spheres appeared manufactured, with surfaces smoothed by extreme heat. The internal note, written by a Japanese researcher, asked, "Source of uniform carbon structures unclear. No volcanic match." The question never entered the published literature. In 1995, the Russian team at Vostok drilled through several compressed layers dating back hundreds of thousands of years. Within one section, dated roughly 220,000 years before present, they found small, metallic fragments embedded in the ice. These fragments measured only micrometers across, yet their composition surprised analysts. They were made of an alloy containing traces of tungsten and copper in ratios not found in natural Antarctic deposits. The Russian team labeled them unknown inclusions. The official summary referred to them only as metallic dust. Another anomaly surfaced during the 2007 Talled Ice project in East Antarctica. At a depth corresponding to the last interglacial period, researchers found a thin film that reflected light in unusual ways. When separated from the surrounding ice, the film showed tiny crystalline patterns embedded within it. These patterns formed repeating hexagonal arrangements. Natural crystals form hexagons, but they rarely form repeating sequences across large surfaces. The internal review described the layer as structurally complex. The public presentation displayed only the chemical composition, omitting the crystalline arrangement. In 2012, an unpublished report from the French-Italian Concordia station mentioned electrical anomalies in a section of newly extracted core. When the core was tested for conductivity, one layer produced a stable electrical signal for more than 3 minutes, far longer than any known natural layer should. The behavior resembled the response of certain engineered materials used to store static charge. The anomaly was not included in the published EPICA data release, appearing only in technician handwritten notes. Perhaps the most curious ice core-related event occurred at a drilling site near Conan Station in 2016. The drill extracted a core segment that contains small, perfectly spherical air bubbles arranged in a near-uniform grid. Natural ice traps bubbles randomly, often compressed by pressure or stretched by flow. But this segment held rows of bubbles, spaced at consistent intervals. A German researcher overseeing the analysis wrote candidly in his private field notes, "These are arranged. This is not glacial." The official report cited sample deformation due to mechanical stress, a possibility, though field observers insisted the core segment showed no signs of drilling distortion. One of the most quietly discussed findings came from a 1,999 joint US-European drill near the Ross Ice Shelf. At a depth exceeding 2,700 meters, researchers encountered a layer containing microscopic particles of unusual magnetism. When exposed to rotating magnetic fields, the particles aligned predictably and maintained that alignment longer than expected. Their properties did not match volcanic magnetite. The layer was described internally as containing remnant magnetic grains. The phrase never made it into the public summary. There are also ice core sections whose data have been withheld entirely. Between 2006 and 2013, several multinational teams drilled deep cores across East Antarctica. Many sections appeared in open databases, but not all. Certain ranges of depth are missing. These gaps appear as innocuous blank entries, labeled Data Under Review. Some researchers who worked on the cores have noted privately that these absent sections contained unexpected particulate results, though no details have been released. Ice cores remain the most direct physical timeline Antarctica can offer. They reveal dust from ancient storms, ash from distant volcanoes, and bubbles of atmosphere trapped since long before human history. Yet they also reveal particles, fibers, metallic grains, electrical anomalies, and structural patterns that have no simple explanation. These findings rarely reach formal publication. They stay instead in margins, small diagrams, or quiet side notes. For now, the ice holds more secrets than it reveals. Each layer, buried deeper than the last, suggests that Antarctica's past contained events, materials, and perhaps conditions not fully reflected in current timelines. The full core records those that remain unpublished, may hold the most important clues of all: the architecture revealed by radar. When ice-penetrating radar became widely used in Antarctica during the 1,970 seconds, it changed how scientists understood the hidden world beneath the continent. Before then, only scattered seismic readings and explorer observations hinted at unusual shapes buried under the ice. Radar made those hints visible: thin lines, sharp angles, and smooth surfaces emerging from the echoes returned by each pulse of energy sent deep into the frozen layers. What surprised researchers was not the presence of mountains or valleys, but the appearance of geometric formations that did not resemble natural landscapes. One of the first anomalies was discovered in 1978 during a joint US-British survey near the Pensacola Mountains. Radar operators noticed a large, rectangular depression beneath nearly 2 kilometers of ice. The depression measured approximately 6 kilometers by 4 kilometers and had edges so straight that early technicians thought the data had been corrupted. After multiple passes confirmed the shape, the team labeled it Block 17, though the official publication described it only as a subglacial basin of unusual regularity. More puzzling data came from the 1,983 SPRI NSF TUD radar transects across East Antarctica. The recordings showed a series of parallel ridges running for almost 120 kilometers. Each ridge measured roughly the same height, with consistent spacing between them. Natural ridges formed by glacial flow tend to vary greatly in distance and elevation, but these remained uniform. A technician's handwritten note from the time reads, "Pattern industrial in character," yet the published paper softened this observation, calling them linear geomorphic features. In 1992, radar mapping of the recovery basin revealed a massive plateau with edges aligned along near-perfect 90-degree angles. The plateau's top surface was unnaturally flat, rising above the surrounding terrain like a concealed platform. Several internal memos raised the question of whether the formation might represent an ancient erosion surface. But erosion rarely produces perfect right angles. A draft document circulated among the radar analysts compared the plateau's geometry to the quarry-cut mesas found in parts of South America. This comparison did not enter any formal publication. By the late 1992s, newer, higher-resolution radar allowed researchers to see deeper through the ice. In 1997, the Agassiz project detected a series of long trenches beneath the Marie Birdland region. The trenches were straight and continuous, measuring nearly 5 kilometers each. Their walls appeared steep and uniform. Unlike glacial channels, which curve and taper irregularly, these trenches retained a consistent width. One radar specialist noted privately that the formations looked like ancient causeways. The project's official report referred to them instead as linear erosional features, though the terminology remained debated among the team. In 2004, a radar sweep over Princess Elizabeth Land captured what is now one of the most debated subglacial formations on the continent. The scan revealed a massive rectangular plateau buried beneath more than 2,700 meters of ice. The outline appeared at multiple frequencies, confirming its presence rather than an artifact. Measuring about 40 kilometers across, the plateau's symmetry was so striking that an internal analysis used the phrase engineered geometry. In published work, it was classified simply as a large, anomalous high-density block. Another significant anomaly was detected in 2007 inches the Aurora subglacial basin. The radar recorded a long, smooth embankment extending for 38 kilometers. Its height remained nearly constant along its entire length. Natural embankments created by meltwater generally show irregular variations. This one did not. When researchers reviewed the shape, several remarked that it resembled an artificial levee. The comment never reached public reports. In 2011, the Ice Bridge program conducted radar passes over the Ellsworth subglacial highlands. The radar data revealed a set of depressions arranged in a circular pattern. Each depression appeared equidistant from the center, forming a ring nearly 9 kilometers in diameter. Circular landscapes do exist in nature through volcanic or impact activity, but no evidence of either was found nearby. A brief internal summary described the pattern as symmetrically distributed cavities. The public-facing analysis removed the word symmetrical. In 2013, a radar traverse west of Dome revealed something even stranger. Beneath the ice lay a grid-like network of shallow rectangular impressions. The shapes measured roughly 300 meters by 200 meters and were arranged in rows separated by consistent intervals. Glaciologists noted that the grid extended for almost 4 kilometers. The official report described the formations as bedrock jointing patterns, though several geologists questioned this interpretation privately, noting that natural jointing rarely forms clean rectangles over such large scales. In 2016, radar surveys across the Wilkes Basin detected a dense cluster of angular voids, small, empty spaces arranged in diagonal lines. The voids had sharp corners and identical shapes. Their arrangement did not resemble fractured stone or meltwater channels. The internal radar assessment described the formation as a complex matrix of voids exhibiting unnatural uniformity. In the peer-reviewed summary, this sentence was replaced with subglacial cavities of uncertain origin. Quote, more recent radar mapping, conducted between 2018 and 2022, has continued to reveal features that challenge natural explanations. One of the clearest new discoveries appears beneath the Queen Maud Mountains, where radar returns show a series of terraced steps descending into a large depression. The steps are evenly spaced, each with nearly identical height. Natural terraces formed by water erosion vary greatly depending on flow. These steps do not. In private discussions at a 2020 geological meeting, several researchers compared the formation to tiered platforms, though none included that language in any published material. The total effect of these radar findings is cumulative. A single straight line could be dismissed. A single rectangle could be ignored. But dozens of them, spread across thousands of kilometers and appearing consistently across decades of radar surveys, begin to form a quiet pattern. A pattern of shapes, flat tops, right angles, parallel lines, grids, terraces, and repeating depressions that suggest more than the random work of ice and stone. Researchers remain cautious. Radar can distort edges, exaggerate angles, or flatten natural curves. But even with these limitations, many of the formations, those confirmed across multiple frequencies and repeated across different missions, retain their geometric precision. For now, the radar images simply record what lies beneath the ice. They do not explain it. They do not identify who or what shaped the buried landscape. They only reveal what the ice has covered, an arrangement of forms that resembles architecture. The heat signatures and buried energy sources. When thermal imaging became reliable in Antarctica during the late 20th century, it was expected to reveal what geologists already understood: diffuse geothermal warmth rising from the crust, scattered hotspots near volcanic regions, and occasional pockets of heat caused by deep fractures. Instead, thermographic surveys began to show patterns that did not match the continent's known geology. These were not random or chaotic distributions of warmth. They were stable, evenly shaped, and in some cases perfectly aligned with the geometric formations already mapped by radar. One of the earliest signals came in 1973, when a British team operating near the Lambert Glacier used sensitive temperature probes to study the basal ice. They detected a warm zone roughly 4 kilometers across. What made the reading unusual was its constancy. Natural geothermal heat flickers and shifts over time, but this heat signature remained steady for the entire 12-day observation period. The team's internal memo referred to it as a thermal plateau. The published report described it more vaguely as localized heat flow. In 1982, a joint US-New Zealand survey detected a circular hotspot beneath the Ross Ice Shelf. The temperature anomaly measured nearly 5 degrees Celsius warmer than surrounding ice. Such warmth was far too high to be explained by geothermal processes alone. The The circle was clean, its edges sharply defined. Natural heat does not form perfect circles in ice. A handwritten note from the project's thermal specialist included the quiet phrase, boundary controlled source. The phrase did not appear in the official summary. More striking evidence emerged in 1991 during an airborne thermal scan of East Antarctica. As the aircraft flew over the Princess Elizabeth Land region, sensors detected a rectangular zone of elevated heat. The rectangle measured approximately 11 kilometers by 7 kilometers. It aligned precisely with a buried structure previously detected by radar. The heat reading was not faint or intermittent. It held a constant value across the entire shape. One internal analysis described it as a thermal object of persistent output, though the official publication attributed the reading to instrument drift. In 2003, researchers studying Lake Vostok recorded something long discussed but rarely clarified. The lake's southern basin emitted steady thermal pulses at intervals too regular for natural convection. Over a 6-month period, small increases in temperature occurred every 39 days, each rise identical to the one before it. Thermal specialists suggested the pulses resembled a regulated cycle. Their internal notes used the phrase mechanically consistent. In public documents, the pulses were reshaped into hydrological fluctuations. Another anomaly surfaced in 2010 near the Aurora subglacial basin. During a seismic thermal survey, instruments detected linear hotspots arranged like long beams of warmth extending through the ice. These beams measured more than 20 kilometers and maintained stable temperatures along their entire length. Natural geothermal lines wander with faults or fractures, but these lines ran perfectly straight. The internal briefing called them conductive pathways. The published report removed the term and replaced it with heat anomalies. In 2014, a German-led geophysical team discovered a strange cluster of hotspots beneath Marie Birdland. They formed a symmetrical diamond shape, each hotspot positioned with almost identical separation. Geothermal clusters do not form perfect diamonds. When the team reviewed the data, some members suggested the pattern could represent subsurface structures generating heat. The suggestion appeared only in meeting transcripts, never in print. One of the most debated cases came in 2016, when Chilean researchers flying over the Bellinghausen Sea recorded faint but repetitive thermal signatures rising through more than a kilometer of ice. The patterns pulsed in a rhythmic sequence, 3 short bursts, followed by a longer one repeating every 14 minutes. Signals of this nature are unknown in subglacial thermal behavior. Ice does not pulse. Ground heat does not repeat in patterns. The internal review called it a structured emission. The public report omitted the entire event. Satellite-based thermal imaging from 2018 through 2022 revealed even more anomalies. Across multiple regions, Princess Astrid Coast, the Wilkes Basin, the vicinity of Dome Sea satellites detected faint, rectangular heat outlines matching earlier radar-mapped structures. These outlines warmed and cooled with surprising stability, their temperature gradients smooth and consistent. Natural terrain does not warm in perfect geometric shapes, yet these forms repeated across separate locations, some hundreds of kilometers apart. One of the most curious findings occurred during a European Space Agency analysis in 2019. A small zone beneath the Shackleton Range emitted a clear thermal profile resembling a grid of evenly spaced warm points. The grid covered nearly 5 kilometers. The ESA's internal model could not reproduce the pattern using any known natural mechanism. A confidential note circulated among analysts suggested the pattern resembled distributed thermal nodes. The public release carefully described the area as possessing complex subsurface heat distribution. In 2022, a rare multidisciplinary review combined radar, seismic, magnetic, and thermal data from the previous 40 years. This internal synthesis, never published but referenced in several meeting notes, found that many of Antarctica's unexplained heat signatures aligned with structures already detected by radar and magnetic instruments. The straight lines, rectangles, terraces, and grids beneath the ice correlated with equally geometric thermal patterns. No natural explanation could account for the alignment of geometry and heat, as the ice sheet should distort, spread, and mask such signatures. The review suggested two possibilities. Either Antarctica contains geological processes, not yet understood processes, capable of creating stable, geometric heat emissions, or the continent preserves remnants of something built during a time when the land was still warm, when rivers flowed, when forests covered the southern crown, something that required energy, something that generated heat. The findings were never released to the public. Portions of the synthesis exist only in fragments, an email reference, a redacted note, a slide title with no accompanying data. The official scientific community continues to describe Antarctica as a realm of ice shaped solely by nature. Yet the instruments used over the last half-century, radar, sonar, magnetometers, thermal sensors, repeat a pattern that nature alone has not been able to confirm. Antarctica remains silent. Beneath its ice lie heat signatures that should not exist, geometric forms that do not match natural terrain, magnetic fields that behave like echoes of forgotten activity, and layers in ice cores containing materials that appear out of place in the planet's known timeline. The ending of this record is not a conclusion. It is simply the last visible layer before the ice hides everything again, a final, quiet indication that what Antarctica preserves is not absence, but memory. Hidden, sealed, and waiting beneath the oldest cold on Earth, Antarctica remains the quietest place on Earth. Yet its silence holds more questions than answers. The ice has hidden landscapes that should not exist, signatures that behave as though something long forgotten still lingers below. Each scan, each core, each faint magnetic pulse offers only another fragment, never a full picture. What this documentary has shown is not a conclusion, but an invitation to look closer at the places the world overlooks. If these hidden shapes and signals truly belong to an ancient chapter of human history, or to something older, still the story is only beginning to surface. If you want to see more deep-dive documentaries like this, exploring the mysteries that sit just beyond what we can explain, make sure to like this video, subscribe to the channel, and turn on notifications. Your support allows these investigations to continue. Share this episode with someone who still believes Antarctica has no secrets left to reveal.